All right, so good afternoon. Today's lesson is about transformations of cosecant and secant, as you see from the aim. Your do now is regarding f of x equals 2 secant 4x, and part A is what is the period of the function, and then part B, I want you to identify the vertical asymptotes of this function. All right, take like 30 seconds. You might not be able to finish, but that's okay. I just wanted to be, I want to get to the classwork because that's the main portion of the lesson today, just graphing, cosecant and secant. Okay. So yeah, just take another 30 seconds and then we'll go over the solution. Okay, did anyone say anything for part A? What is the period of this function?
I said it was pi over 2.
Pi over 2? Okay, how did you get pi over 2?
I just put 4. I did 2 pi over 4 and then I got pi over 2.
All right, okay, and then I see Aoyan also responded pi over 2. Okay, good. So it's gonna be pi over 2. And then what about the vertical asymptotes? Anyone get those? Yeah, Alice?
For vertical asymptotes, I got pi over 8 and 3 pi over 8.
All right, I think that's correct. So let me confirm that. I'm going to move up to the solution. Okay, but yeah, I think it is pi over 8, 3 pi over 8. Okay. All right, so yeah, here are the answers. As Jocelyn and Aoyan said, it's pi over 2 for part A. And then for part B, I would make a chart. And then as you see from the chart, as Alice said, that the vertical asymptotes occur at pi over 8 and 3 pi over 8. Okay. But yeah, let me go through the chart. So normally it's 0 to pi for secant x. And then from there, we divide everything by 4, right, to get the next row. And then for the y coordinates, it's 1 plus minus infinity, -1 plus minus infinity, 1. And then there's a vertical stretch by a factor of 2. So this becomes 2, this becomes -2, and this becomes 2. Everything else, the infinities, they stay the same. Okay. But yeah, as we see, right, the vertical asymptotes, right, as you see from the y coordinates being plus or minus infinity, they occur at x equals pi over 8 and x equals 3 pi over 8. Okay, so that'd be your answer for part B. Okay. All right, does anyone still need this? Please speak up now. Okay, all right, gonna move on then. I will post the lesson plan, so you'll see all the solutions on Google Classroom. But yeah, you can still let me know if you want to copy it down now. It's fine. For the example, okay, here's our next question that I want to pose to you. We're just going to graph the function from the do now. So luckily, we already made the table. And as you can see here, I sketched the graph. So for my x-axis, I go by an interval or an increment of pi over 8 each time. Well, technically it's pi over 16. I divide that by in half. But here's pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. 4 pi over 8 is the same thing as pi over 2, right? Anyhow, the y coordinates are gonna, they're gonna be it's gonna be 2 for 0, so 0, 2. There's a vertical asymptote at pi over 8. Then at 2 pi over 8, it's -2. Then at 3 pi over 8, there's another vertical asymptote. And then at 4 pi over 8, it's 2 again. Okay, and then you draw the curves. So for secant, remember the frowny face. So you draw a loop here, then a loop here, and then another loop here. All right, any questions or comments about this? Okay, if not, then I'm gonna prompt you to start the classwork. Okay, well, there's the first answer, but yeah, so on Google Classroom, I posted a PDF of the classwork. So for the next 8 minutes or so, I want you to work on that classwork. So again, please go to Google Classroom and start the classwork. You see it on the screen here, the first 2 problems, but yeah, there's 4 graphs in total that I want you to work on. Okay, so take the next 8 minutes, work on the classwork. And I'll pause the recording here. Oh yeah, you can just start talking. Yeah, Justin.
Wait, is it really loud in the back?
A little bit.
Okay, actually, is it like not that? Okay, sorry, it's my brother. Give me a sec. Okay, so the period would be pi over 2. So I just put down the x coordinates for, like, I just put down like the regular x coordinates, and then I divided all of them by 2, and then I got, oh no, by 4. Sorry, and then I got the second row. And then after that, I put down all the y coordinates, which you see right there. And then I multiplied all of them by 2. So then the infinities would stay the same. And there would be 2, infinity, -2, infinity. And then 0, pi over 4, and pi over 2 would be the vertical asymptotes. So yeah, that's it.
All right, and then yeah, for the graph, very nice. Yeah, for pi over 8, it's 2. And then for 3 pi over 8, it's -2, as Jocelyn said. And then, yeah, for the cosecant graph, it's 1 positive loop and 1 negative loop, as you see here. Okay, so that'll be your solution to question 1. Okay. Note here that I also denote a is equal to 2. So I don't write amplitude because technically cosecant and secant don't have amplitudes. Same thing for tangent and cotangent, right? You know, reason for that being amplitude, we normally denote as like a finite max value. So, you know, there's, you know, these graphs, the other 4 graphs go to infinity. So that's why we don't say amplitude. So here I just write a value, right? A equals 2 here. All right, does anyone still need this for a solution? Please speak up now. No? Okay. Gonna move on to 2 then. All right, does anyone want to walk us through question 2? You feel comfortable enough? Yeah, Pepper?
All right, so I'm just gonna I guess start with the table you have here. So these are the regular x coordinates.
Pepper, is there, sorry, the volume's kind of low. Any way you can like get closer to the mic or something?
Wait, is it better now if I get closer here?
Yeah, that's a little better. Yeah.
All right, so I'm just gonna start with the table. I don't really want to analyze this work. So basically, the equation here, you just factored out 2, which is, so you isolate the k variable so you can find your period. You would do 2 pi over 2. That gives you your period of just pi. Now you have to use that to find your points. So besides the period, you also have a phase shift, which you get after factoring out the 2, which is pi over 4 to the left. So you would just subtract pi over 4. So our points, you would get them you could divide pi by 4. You get pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. And after doing that, you would subtract your pi over 4 and you get negative pi over 4, 0, pi over 4, 2 pi over 4, and 3 pi over 4. And for your y coordinate, you have this 1/2 value, you would just multiply. When you multiply it to the asymptotes, they're obviously not going to change since it's an infinity. But when you have pi over 2 and 3 pi over 2, the y coordinates are those. It would just be 1/2 and negative 1/2. And you just have your graph here with the dotted lines, which represent asymptotes. Yeah.
All right, thank you for that. So just one thing I want to emphasize though. So the phase shift, just make sure you guys know that's negative pi over 4 objectively, okay? So objectively speaking, the phase shift is negative pi over 4. So if you say pi over 4 to the left, that would technically be wrong. Yeah, just make sure it's negative pi over 4. Okay. Like that's the actual number, that's the phase shift. Like phase shift equals negative pi over 4. Okay. Yeah, I just see that mistake a lot, so just make sure you get that. Yeah, get that clear. Okay. Anyways, let me just go through the graph. So thank you, Bipper, for explaining the table. But yeah, the graph should be pretty easy now. This is the graph from the old textbook. It's in pink here. The purple are the other loops that we don't have to necessarily show. But yeah, so we start off at negative power of 4, plus minus infinity. So that's why you see the dotted line there. And then there's another asymptote at power of 4. So there's another dotted line. And then lastly, 3 power of 4. That's our third asymptote. And then at 0, there's y coordinate of 1/2, which you see here. And then that's going to be followed by 2 power of 4, which is here, negative 1/2. Okay, and then you just draw the loops in, as you see here. All right, any questions or comments about this? Okay, if not, then I'll move on. All right, anyone for 3? All right, Alfred?
Yeah, okay, so we have the equation y equals secant parentheses x plus pi over 4. So from this equation, we know that the a value and the period are both 1. And so the total period for this function should just be 2 pi, but there is a phase shift of negative pi over 4. So in the table, we have the x coordinates for your regular secant x function, so 0, pi over 2 pi, 3 pi over 2, and 2 pi. And since there's a phase shift of negative 4, you subtract from each of the values. So 0 minus pi over 4 is negative pi over 4, then pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then the y coordinates for the regular secant x function are the same for this function, since the a value for both is just 1. So you would just keep them the same. So wherever cosine is 1, or yeah, wherever cosine is 1 or like undefined. So well, at 0 it'd be 1, at pi over 2 it's infinity, and at pi it's negative 1, at 3 pi over 2 it's plus minus infinity, and 2 pi it's also 1. And the two negative infinities just represent the asymptotes at pi over 4 and 5 pi over 4. And
All right, thank you for that. So yeah, these are our coordinates here. So second row is x coordinates, third row would be the y coordinates. So I made a small mistake with the graph. I initially thought it was going to be like a small graph, but yeah, I had to extend the x-axis. So don't mind that. This is the x-axis. I extended to, I was originally thought it would end like around here, but no, it went like double that. So yeah, negative power of 4, y coordinate at 1, and then power of 4 asymptote there. 3 power of 4, it's negative 1, 5 power of 4 asymptote there, and then 7 power of 4, 1. Okay, and then you draw your loops in, right? Secant looks like a frowny face, so you draw the first loop here, then the negative loop here, and then the last loop. Okay. All right, so this is what this graph will look like. Does anyone still need this? No. Okay, if not, I'll move on to the last one, question 4. All right, any volunteers to walk us through this one? Let's go to, all right, I'm gonna call in someone. Sunny, are you there? So Sunny or Richard? Or James? All right, I'll try one more. Randall? Randall, are you there?
Yeah, I'm here.
All right, could you explain this question 4 for us? Or like walk us through it? I know the solution's here, but yeah, can you walk us through the solution?
I'm a bit confused right now.
Okay, all
To
right,
tell
no
the
problem.
truth.
Okay, I'll go ahead and explain this one then. Yeah, so just really quickly, 3 secant pi of x plus 1/2. I rewrote the sum as a difference, so it's gonna be x minus negative 1/2. A value is 3. Period is 2 pi divided by pi. That's this coefficient right here. So the period is 2. Phase shift is negative 1/2. That's this number right here, which means to the left, right? The x coordinates normally for secant 0 to 2 pi. Then we're going to divide by pi for the period change. So divide each of the first row coordinates by pi, you get 0 to 2. And then you apply the phase shift, so you subtract by 1/2, you get negative 0.5 to 1.5. Y coordinates, these are the normal y coordinates for secant. And then for the vertical stretch, you stretch by a factor of 3, so multiply everything by 3. You get 3 plus minus infinity, negative 3 plus minus infinity, 3. Okay, for the graph itself, it's, yeah, so you just graph these coordinates. This row is the x coordinates. This last row are the y coordinates. And then you have negative 0.53 here, asymptote at the y-axis. 0.5 negative 3 is here, then 1 asymptote there, and then 1.53, which is shown here. And then you draw your loops in. Here's the first loop, negative loop, and then the second positive loop. And that would be your secant graph for question 4. Okay, just really quickly before we close, announcements. First, there is SGI in 5 minutes in case you have questions, so drop by if, yeah, if you want to ask me anything. Second thing is reminder that our quiz is this Friday, so it'll be during class on Alex, 25 minutes, about 5 questions. Okay. All right, so if there are no other questions or comments, you're free to go, and I'll see you all tomorrow. All right, take care.
Have a good day.
All right,
Have a
thanks.
great day. Thank you.
You too.